for some of our design. So standard ring, here we've got 6 switches on the left, and those 6 switches are just in a very standard ring, throwing information around. Now you imagine if one of those switches goes down, we have redundancy. That means we can go the other way to get to the switch. So we can think and factor in how we got that redundancy. So what we need to do is implement some technology into that to stop it having that broadcast storm. But we still want the ring. The ring is very handy for us. Now on the right hand side is star topology. This might be something that is more familiar because it's got that core concept. Now the benefit of that star topology means that if you think about hop wise, it's very close. So it's always going one hop to get to that core switch, and if it wants to go to something on the edge, it's only 2 hops away, right? So it's 2 hops. It's very optimal in terms of sending traffic. But think about it, if that core switch goes down, that's a problem because the whole network goes down. You've lost everything.
That's the exact question I was going to ask then, Greg. What happens to if the core switch goes down in this case? Because there's no connection between the switches on the edge at all, is there? So
absolutely, yeah. There's nothing. There's absolutely nothing, and that's kind of unfortunately we see this design a lot. It's an older design, but what we want to do is we want to merge these two together. So if you look on the left, if we have one of the switches goes down, yes, we can still get there. But think about how many switches that has to go through if those 2 switches are furthest points away from each other. We have to send all that traffic through the switch, which means every switch has to be able to handle its own traffic plus the traffic of the other switches as well. So yes, it's got redundancy. The other one doesn't. But the other one has this optimal pathing that we can send information on, but doesn't have the redundancy.
I wonder where you're going with this, Craig.
Where am I going? Where am I going, Dan?
I think I know because I can already see the next slide.
Yeah, here we go. So meshing and partial meshing. These are topologies that we want to implement, really. Now, notice the one on the left. This is full redundancy, right? If any one of those switches goes down, it can always get to the other switch. It's direct. It's 1 hop away. Great. However, in a real world scenario, cabling costs money, right? So it costs money. We want to reduce the amount of money that we spend, right? That's a no-brainer. We can't throw in everything that we want because otherwise we'd all be riding Ferraris, right? So what we want to do is we want to keep our redundancy. We might have to lower it perhaps, but we can still have something that's a really good design. So keep our redundancy, keep that optimal pathing, but also keep the costs down. So these are things that we have to factor in when we do our network designs, because obviously these are 3 things that we must have in order to keep our business running. You can't throw money all over the place and buy everything all in one go. That works absolutely amazing. Like a data center, everybody has their limits and their budget, and it's about meeting your budget and trying to factor in pathing and optimal sending, and you're keeping your network optimal plus that redundancy period. Okay. So spanning tree protocol. What is spanning tree protocol? Spanning tree means that we are introducing our redundant links, right? So what you want to do on a managed network is create redundancy where we can have those pathing. So here is an example where I'm sending traffic from A to C as an example, right? So I can see that I've got A to B, that's fine, B to C, that's fine. My redundant link is A to C. Now, you might think to yourself, well, that doesn't seem really beneficial because I've got a link that goes from A to C and I want to send traffic across that way. Wouldn't it be better? Sometimes yes, sometimes no. Sometimes it's just a case of having that link available to you, coming up and coming down when it's needed. Okay, so the next step would be the second step of spanning tree protocol, where we can choose how that information flows to get from A to C and C to B, right? That's what spanning tree allows you to do. It allows you to create these root bridges that can define the shortest path how to get to somewhere. However, we have our backup link. Now, what spanning tree protocol will do is it will recognize the traffic that is sending across those ports, and it won't create that broadcast storm. So it's very simple to actually implement. All you have to do is go onto the switch itself and implement the spanning tree protocol. It's literally just a global setting, and as long as it's on every one of your switches, they'll understand that they can pass on, and generally what they'll do is they'll choose the fastest path anyway to get to those devices, but it won't do it in such a way that breaks your network. So sometimes just implementing spanning tree protocol is enough to get that link going.
To make use of this kind of spanning tree protocol, Craig, do you need a smart switch? Is that kind of the entry level for this kind of protocol, or is it on an unmanaged switch, for instance?
Yeah, that's a really good question, Alan. It's not going to be on an unmanaged switch, right? I can tell you that now. And reason being is it has to have some logic there in order to understand it.
Right.
You have to implement it as well. So it's an on-off feature. And generally, you're not going to find on anything other than something that's either smart or managed, okay? The problem comes from implementing unmanaged switches into a design like this. It is possible, however, it must be done on the edge, and it mustn't be part of that routing block either. So generally what we can do is, let's say we have a smaller unmanaged switch plugged into A, that's fine. A, we can do our logic, and the switch itself, when it hits A, will then join the rest of the network. However, if you try to have A as your unmanaged switch, that's not going to work. It's not going to be able to do it properly.
Yeah. Well, cool.